Okay. So I think it's able to run it, right? So yeah, so I will carry on. I think something is there. You can let me know. So there are few steps is there, just like import keras and keras model import sequential. Sequential is the very basic implementation of neural networks.
Mm.
So this is a plain data. So we are using sequential method.
Mm.
And when we'll be using CNN and RNN, obviously we'll be having different technique. So Keras model import sequential and Keras.layers import dense. These two are required essentials. So what is dense is to create the number of layers, numbers of hidden layers. So what is the hidden layers now? We'll be seeing like this one.
So, sir, I have one question, sir. Sir,
Yes.
in TensorFlow also we'll be using hidden layers, no, sir. So, for a TensorFlow, how we are going to create the hidden layers?
What is it?
Sir, you have taken import keras, and from keras you are importing sequential and dense layers. So for the tensor, if you want to use for a TensorFlow, then we
Uh,
write input TensorFlow as TF, and
uh,
from TF dot models we need to import sequential, and TF dot layers import dense. Only that's the difference, sir.
yes. The way of writing is different. Internally, it's TensorFlow only, right? So when you're using this step is getting more clarity when you use it. Tensor keras and other clarity is it provides you other functionalities to convert your uh, text or your image data to a matrix. You can create your this one binary matrix with some easy methods.
Okay. Generally, most of the computer vision algorithms are running with keras. I think some TensorFlow also some vision algorithms are running like
Yes. Keras is there.
YOLO
Keras is
algorithm.
more, user friendly and easy to implement.
Yeah,
So it is.
like YOLO algorithm, and Google Inception. Yeah. So,
So yeah, we'll see if TensorFlow. Some example we'll be using only TensorFlow only without Keras also. So, so as a neural networks is like solving problem is something like in the text classification I have seen. So it's about not like a machine learning problem. So it requires sometimes many programming also.
hmm.
So because we have to read the data from many other format, some PDF also you might be you wanted to read and then you wanted to work on it, and that's why. And how you are going to create a matrix, what kind of things. So more steps are required, but in the machine learning, it's concepts is more, but programming effort is very less.
Hmm.
So classifier dot. So this is the sequential methods we borrowed, and sequential dot add dense. So in the dense, what is the? This is the one layer of neural networks. So this is the hidden layer, right? So this is known as the input layer. So this is x1, x2, x3. If you see this one, these are the
Hmm.
features. So these are the
Hmm.
features, column name. And here input data
Okay.
will come. Input data will come. Then some weight will be there, and then they will produce a output. So
Hmm.
here,
Hmm.
so here it is. So here is the two output will be created.
Hmm.
So and if it is, so idea is to in the hidden layer we create like this. You can put any kind of nodes, but how we do is generally input nodes we can divide it like in the middle layers. You can put it to half of the value. You can minimize it and keep it kind of similar. Then you ultimately output is what? If it's a binary problem,
Some
get only two. If it's a tree classification, three. It's a 10, then 10.
No, sir. No. Like 1 minute, sir. It's not based on the number of times we have created the neural networks. Depending on the output values, you are going to get the script.
Pardon?
Sir, if we have in this case we have taken two hidden layers, no, sir. Layer 2, layer 3.
Correct.
So the output function is not dependent on the number of layers you have created. It depends on the type of the output. Like it may be
Yes, yes.
one type
It's the time,
classification, not.
yeah, that's what I'm saying. Now our problem is two. That's why you have two layers here. And when you
Mm-hmm.
have three classifications, what you'll do? Three layers will be there, right? It's three layers will
Okay.
be there.
Like the output layers can have 100, like they may have 50 hidden layers, 60 hidden layers, 100 hidden layers, but the output will remain on the type of the classification
Output
we
is
want to
depend
do.
on the type of your output,
Not the number of hidden layers. Okay,
not the hidden layers. So here, if you see output, our problem is two. So the last layer is the output layer where we are putting the number of things you wanted to classify. So which is classification problem. So I'm talking about classification. So one means two only. So and generally, if there is a 10 output is there, 10 types. So we're putting 10. But when it's a binary, you have to put one. So that is the standard. In binary, we cannot put two. So if you
sir,
put
like
two, some error will come. Then will show you.
sir, like something say, if I want to recognize a 5 persons woman face, then the output dimensions will be 5, sir.
Pardon?
If I want to recognize 5 persons, if I want to recognize using deep learning, so the
Ah.
output dimensions will be 5.
Yeah, 5%. You are not going to five types of person, right? Five types.
It's a 5 types, sir. Yes, sir.
Yes, it's still five only. Yeah.
Then it is 5. Okay. Like that neural networks like this, how much can be support, sir? Suppose if there are 1,000 persons, can it be recognized 1,000 persons?
1,000.
Suppose there are 1,000 persons, so can a neural network be trained for the 1,000 persons? And can we create a 1,000 dimensions for
No,
that?
no. See, so you will be doing 1,000 persons. Yeah, correct. So 1,000 persons, different persons will be there, right? So
1,000 different.
yeah, so every person will have thousands or hundreds of images again. Your image
Also,
will be 100 images to find out that it's you
yeah.
only.
Yes, sir.
Yes, so your 100 image will be there, but then my image will be there. So then yes, out of that output will be there 100 different 1,000. You said the 1,000 people will be there. The 1,000 images. 1,000 is the output then.
Sorry, sir. 1,000 is the output. Okay. 100 images. Okay.
And how it is going to run based on the CNN, it will run on the every time it will check how it will learn because the 100 image is required to train because every person has to be trained with 100 different images. The more it
Okay.
is said that more different. Generally, the idea generally for one thing, the more images will be there, there will be different. It can learn better way because
That's what, sir. The accuracy will be improving, sir. I know, sir, because number of like one now the new algorithm has came, sir, like one-shot learning algorithm where it uses the triplet loss and using one-shot algorithm where we can train only with one algorithm. But I don't know how it's implemented. But this one-shot learning algorithm.
yeah, it's there.
Yes.
So see, it's yeah. So everybody's trying to put last standard, but then again modification will be happening. And so when you work on a CNN, that you have to put you have to depend on many open source images. You cannot bring many images, right? So we have to rely on the open source database of data.
Yes.
So here what you've seen, the ReLU activation functions we have used and input dimension we have put 13 because 13 is the dimension of your this one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13 will be there. So except Y output there will be 13 features are there.
Sir, you have removed the unwanted data set also, sir. Unwanted data set also removing. It is 13.
Yes, remove, no? Here it is remove already.
Not output, sir. Not output. I'm saying the
Features.
yeah, features, unwanted features. Yes, sir.
Yeah, these features are removed, no? Surname, roll number.
Okay, after removing, we have 13.
Yeah, after removing and after doing the hot encoding, is you getting 13. So just before that, whenever the last X is there, right? So last X is
What is hot encoding, sir?
hot encoding is converting the genders, object data type to binary using getDummies method. So in the data set, column number, geography, and gender, which having multiple object type that machine cannot understand. So we put in this method getDummies, which is converted to the different types. This you already attended class earlier, right? So gender has geography has three types. So three different columns are created. This is the France is there. So 792 row number will have one for France. So like that.
Converting the data set to binary format is a hot encoding.
Yes. So yeah, you already understand, right? So that one. So it's zero number row has a France as a one. Why? Because it's a France, right? One number has a Spain. Two has a France again. Huh? So 1011 has been happened, and this is automatically created. Geography underscore France. The column names are already will automatically create. So understood, right? So there are 13 columns are there, plus X. So that's why. So I will run it again at the last moment. I mean, I will run it so to see the neural network. So after that, we did a scaling and neural networks. When we create, we put the input dimension, column input features, and activation. I put ReLU. The input initial layer you can put any activation function. The last one will, if it is a binary, we have to force to put a sigmoid.
Okay.
Yeah. So because the binary problem, and the output dimension is put to 1. So here it is a 3 layers are there. So it's a deep learning. Only one layer will be there, then it's a neural network.
Can you repeat the point, sir?
Only one layer will be there, then we call it neural networks. When more than one layer are there, it's a deep learning. So there are 3 layers are there. So output
dimension
is 13 and we provided the output dimension 6. Again, the next level output will be 6 and the last one is 1. So
that is the output layer. Only one classification. Okay.
1, yeah. 2 classifications, so we have to put 1.
Sorry, so 2 classifications means 1, sir?
Yes, it is. They have created like this only. For 2 is 1 only. But 3 is 3 only, 4 is 4 only.
Oh. For 3 is 3, 4 is 4, for 2 is only 1. Okay. It's internal. Okay. And sir, why we are using here activation of sigmoid, sir, for output layer? For other
Sigmoid you already understand, right? Logistic regression. Sigmoid is a sigmoid graphics for a 0 and 1, right?
Okay. For hidden layers, we will be using a ReLU. Hidden layers, we will be using ReLU.
For any other problem, you can put ReLU or tangent, but ReLU is most popular, and ReLU we already seen, right? Half tangent, half 0, and then it will like a increasing order, right?
Okay, sir.
So you can look at that the PPT, and then you see. So next step is you created this layer. You created in the neural networks. These steps will create not the data we filled it, but we have created a layer how the data is going to pass through it. Yeah, we require variable where memory, right? So this way it is going to create some nodes, and there is going to be data will be the variables value will getting go with these layers. Like we have the pipes are there, the water will flow into it.
Okay, sir.
So in compile, we have to put some optimizer. Optimizer is what is like a optimize the learning rate. Like it will increase the accuracy. Optimization is some optimization method is there. One is the Adam. So
Sir, 1 minute. So what do you mean by model optimizer? So model optimizer, like it will be converting the TensorFlow models to XML file and .bin file. Model optimizer. So it's
don't understand what you're saying. Maybe after the class we'll see. XML,
okay, sir.
XML. You are saying about the XML?
So we need to convert our trained models to XML file and XML files our trained models. So for that one, we are using model optimizer, sir,
No,
generally
no,
for.
no. That is different. So optimizer is
Okay.
the learning rate. I will tell you the learning rate is how the model is going to learn. How we can increase the learning rate. We can decrease our Adam is a pattern.
Mm-hmm.
So Adam is a pattern where it is going to smooth. There is a learning rate is good. It's not too hurry. So when we wanted to our algorithm to learn very quickly, so it can overshoot means it can not convex. It is can overshoot means what you wanted to go down from the top of a hill, and if you put a very long jump, you may cross the hill and fall into other part. But your intention is to take a small step.
I see.
So that is a learning rate. So learning rate is adjusted in Adam. So the formula is there for you. And one day I discussed with Amitav on class the learning rate. So
Okay.
so Adam is the most popular optimizer. So you can use it and
Like optimizer, basically it will make the learning rate improve.
yeah, what will happen? So how is going to learn? This is the input parameter you can put. When you compile this one data, so optimizer will tune it to increase the, not tune, optimizer will see the how quickly it's going to learn. Using this, no? Learning means what? Sigma, this pattern, right? Using a Sigma graph on this data, how it is going to uh, yeah, how it's going to fall in, I mean, the base learning. Let's say every step, like if you see the gradient descent we talk about, so the gradient of the graph changes, right, as it learns. The gradient changes, correct?
Yes, sir. Yes, sir.
So I will show you. I will show you one program where it is a life of how the algorithm changes its learning rate. So in the neural network, I will show you one immediately after this program. So then you can get to sense that how it is the learning happen, how optimizer is working. So binary cross entropy is what? How the loss function will work. Loss is because there is two type of this parameter is there. One is categorical cross entropy. One is binary. When you have more than two output, then you will go categorical cross entropy instead of binary.
Sir, I not understood what you mean by binary cross entropy.
So you have seen that loss function. Loss when the loss will be when you run this one, you are going to see there is a loss is there, right? Every time
It's a loss.
actual
It's
accuracy will be expected and there will be a loss. So loss is the
yes.
error. So how to measure the error and reduce the error and get into more accuracy?
Using loss function. Okay.
That is the loss. So that is loss is using binary cross entropy because we are using we are binary problem. If you are working on category, I mean more than two classification problem, then you have to use categorical cross entropy. This is categorical cross entropy when you have more than two problems. So it is definition.
Neural networks. Sir, the syntax it will be the same for either if you take for image classification or for any applications like images or any
Yes, when you
text
use
generation.
Keras, the syntax will be same only. See, here it is. See, one is loss function categorical cross entropy when you are using more than two classification problem, and else you have to use binary cross based on the problem type. And when it's you can use mean squared error. When you can use mean squared error when you have a linear regression problem. Regression problem.
Linear.
Yeah, linear problem. Mean squared error. Linear regression problem like a Boston data set. If you have to solve mean squared error. So mean squared error we can use using when tell me that linear regression if you wanted to solve it. We'll do like regression problem. We'll also work on that TensorFlow.
Okay. One problem is solving TensorFlow, sir. Now we are solving Keras on TensorFlow. If you do, sir, you'll be teaching image classification also, no, sir? Using deep learning. One
Yes,
problem also.
yes. CNN will do. So this one is has been checked. So this is the next after the creating the network. This is the compile is how we are going to make the loss. How we are going to increase the accuracy. Matrix is accuracy because why? This is a classification problem.
Yes, sir.
And optimizer always you put Adam is the base optimizer. So yeah, I will show you a graph optimizer how it's based. So there are three types of optimizers. You can see it in the best gradient and what is the gradient is there gradient you missed the class gradient class. So classifier that feed that train this data is already there. This is the simple we do as usual. White train, batch size, and this. So after that, we created a compile the network using this method, and we created the network before that using Keras dance there. So fit when you do cell run all. So fit when you do, then the algorithm actually runs. So number of iterations we provided 30.
Okay, it will done till 30 times.
That means our whole things will do 30 times.
And batch size?
So that means what you can think of, I will tell you now. As it started running Epoch, I will tell you. So now it is running all the data and using the learning 3 layers. 3 layers are there, right? We have used 3 layers, correct? Here it's C 1 to 3, right?
Yeah, activation input one layer, output layer, and hidden layer.
Middle layer. So all iterations, all data will run in the 3 layers and get into this accuracy and this loss function. Again, we'll do the same thing again. Again, we'll do the same thing again and again and again. So the idea is to increase and this is the mean accuracy. All the row, the mean ultimately. There is a 1, there is a 0 output, right? 0 then 1 output. So every time it's not means 100%. So
yes, sir.
and based on that, what is happening? The weightage has been changed. According to the laws, weight has been changed, and again, whole samples records will be go through that network, and again, we'll get accuracy. So this is a continuous process.
Okay, sir. Like, how many iterations can we take? Sir, basically, like generally, if I want for 100%, if I want for 100%, suppose if I want about 90% above accuracy, so how we can calculate the number of iterations? Say, how there's any formula or how we can do it?
Yeah. There. You can put also trial and error. There is more we can do. We can work on hyperparameters, learning rate. We can work
Uh,
on
you,
yeah. We can
you
work on
took the we finished that class. We did not finish the topic, no sir. Hyperparameters tuning. We did not finish, no sir.
no, not the hyperparameters we have to cover.
Okay, sir. Okay, sir. We will discuss it there. There, sir. But generally, you can see the time it is taken to run this program in CPU is somewhat more like. But when we run the same program in GPU, I think the time will be very less. I think the number of iterations
Yes,
you
it is all about your system speed.